Hi class, someone has requested me to work out question 1 on REQ 12, section 1.2. If you do not want to see the solution, I would stop watching the video. So the question says, suppose I know that 4 reds equals, well, that's not a good start. Let's try that again. 6 reds equals 3 yellows, and 7 green equal 9 yellows, and 12 white equal 14 green, and that 9 blue equal 2 white. They want us to answer the question. Answer 24 reds equals how many blues? I put the colors associated. They say R, Y, B, and G, but we can make the jump. It's nice to have something to work with. All right, so when you're doing a problem like this, these are going to help us to make the conversion. However, this right here, that's what we are actually trying to answer. So this is going to be our starting place, this 24 reds. So 24 reds, and it doesn't have a denominator, so I'll just put a 1 just because we're going to do a string of fractions on this. We can, at this point, kind of see what the next jump could be. We have something to help us go from reds to yellows, yellows to greens, greens to whites, and whites to blue. So this tells us how many are equal. So I could use this as 9 blues equal to 2 whites as being 9 blue over 2 whites, which is a form of 1. Or 2 whites over 9 blues, which is a form of 1 as well. Mainly because they have the same amount. Think about if you had 5 divided by 5, that's equivalent to the to 1. We use this multiplying by a form of 1 as pretty often a tool in mathematics. All right, so when we set this up, we want to set this up in such a way that our reds will move and cancel out. So we need a reds across out, and in this case we have 6 reds for every 3 yellows. So 6 reds for 3 yellows. If I stopped right now and multiplied, I would end up with yellows, a number of yellows. And we want to keep doing this. Now going from yellows to greens, we know that with yellows being on top and we want to cross those out, we want numerator and denominator cross out. And we also know that there are 7 greens for every 9 yellows. So there are 7 green for 9 yellows. Again, if I stopped here and multiplied across numerator and denominator, I would have a number of greens. But our final answer we'd like to be in blues. So a couple more before we multiply it out. We have a way to go from greens to whites. We know that the greens have to be on bottom, again, to cancel out. So the 14 greens for every 12 whites. Stopping right now, we'd have a quantity of whites. Last bit was to go from whites to blue. We know that for every 2 whites, we have 9 blue. And we want those whites to cancel out, numerator to denominator. So we have 2 whites for 9 blues. So if I was to cross out the whites, my final answer will be in the appropriate units of blue. Now I get to multiply numerator and denominator. Just for the sake of ease, I'm going to multiply all those pieces. 24 times 3 times 7 times 12 times 9. And I'm getting 5, and I'm going to give you the unreduced version. 54,432 over, and then multiplying all the denominators. The 1 times the 6 times the 9 times the 14 times the 2. So 28 times 54, 15, 12. Sorry. Reducing that down, let's see if these come out clean. It may not. 54432 divided by 1512. We get 36 blues. There you go. I hope that was helpful. Feel free to watch some more dimensional analysis. That's essentially what this is doing. This is just one such example of that, but there are a lot of videos on YouTube with that topic if this is eating your lunch. Hang in there. You can do it. Bye.